Welcome back. So our next topic here in Unit 3 is the idea of multiplying and dividing these rational functions. You're going to find this to be very similar to our simplifying of rational expressions, just only instead of having one fraction to deal with, we're going to be multiplying two of them together or dividing two of them together. So it'll be about factoring going on as well as applying our multiplying and dividing rules. So the idea behind multiplying two rational expressions, you're going to factor everything as far as possible because you're going to want to cancel out common expressions. The last thing you want to do is try and multiply two quadratics together to create an x to the fourth expression and then try and simplify it from there. It's similar to the idea that when you're multiplying with just numerical fractions, you want to try and generally reduce them before you start multiplying to make the numbers smaller before they get bigger. Again, so the common expressions cancel out. The excluded values are, again, all the original solutions to all the original denominators, same as it was for the simplifying of the rational expressions. So we have here 25 minus x squared over x squared plus x minus 30, and then times x squared plus 3x minus 18 over x squared plus 2x minus 15. So again, there's going to be a lot of different simplifying quadratics going on here and factoring quadratics. So again, you really need to make sure this is a comfortable skill of yours so you can go through relatively quickly. So the top will be 5 minus x and then 5 plus x. Bottom would be x plus 6 and x minus 5. And then this next top factors as x plus 6 and x minus 3. And then down here we have x plus 5 and x minus 3. So looking to see what cancels. Well, I recognize over each other vertically, x minus 3's cancel, as well as the x minus 5 and 5 minus x, remembering that a negative 1 gets left behind, because that's our additive inverse idea, where they're the exact same expressions, just opposite signs across the board. Now, in addition to reducing it vertically, we can also reduce it diagonally. As long as it's a numerator and denominator, same exact expression, they cancel. So the 5 plus x, x plus 5 cancel. Those are not additive inverses because they're the exact same expressions, just different order. Nothing's this different. Positive x, positive 5, and positive 5. Whereas the 5 minus x and x minus 5, we have switched where the negative signs goes. And the x plus 6 also cancel, so you can see every single expression cancels, which may not have appeared to look like that from the very beginning, given the nature of each of those quadratics. They all looked very different, but in reality, after factoring, they're all gone. Now, when we're canceling, because we're technically dividing the like expressions, we're leaving ones behind, so it's not a 0 for the answer, it's a whole bunch of ones and a negative 1, which means our final result is negative 1. Now, we do need to talk about excluded values, though. The answer is negative 1, but x could not equal certain answers. From the x plus 6, we couldn't get a negative 6. The minus 5, we can get a positive 5. The plus 5 can give us a negative, so it's plus or minus there. And then a 3 from the x minus 3 expression. So while there is no more algebraic expression there, no more real rational function, we still need to talk about our excluded values, which are still all the solutions of each of the denominators. Again, x plus 6 giving us the negative 6, x minus 5 giving us the 5, x plus 5 the negative 5, and then x minus 3 the positive 3. All right, so you really have 4 different quadratic factoring into one problem, and you're just multiplying and canceling. Same thing can happen with dividing. We just have to remember our basic grade school rule of keep, change, and flip. When we divide two fractions, we multiply by the reciprocal. Once we do that, it's the exact same problem as the previous thing we just talked about, which is the multiplication step. Exclude values, though, you have to be a little more careful. They're all the original solutions of the denominators, which both include before and after the flip. So in reality, for these kind of problems, the only thing that's not going to count towards the excluded value is the first fraction's numerator. Because the second fraction, as we can see right here, we're going to have to account for the 3x squared plus 13x plus 4. It's the original denominator. And when we flip it, we're going to have to account for the new denominator of 2x squared plus 5x minus 12. So this denominator right here, this one, and then this numerator we're going to have to account for exclude, because when we rewrite it, we're going to find that it changes, it flips over, and gives us our new denominator we have to worry about. All right, so then after flipping it, now just a matter of factoring each of these expressions, seeing what's going to cancel each other out. So we have the 2x squared plus 13x minus 24. So we know that's going to be a 2x minus 3 and an x plus 8. to give us our negative 24, negative 3 times the 8, and then the 2 times 8, negative 3 times the 1, give us that positive 13. 3x squared plus 7x plus 2. We're going to have that as 3x plus 1 and x plus 2. That gives us what we're looking for each of those. On the other side, 3x squared plus 13x plus 4 will be 3x plus 1 and x plus 4. And then finally, the 2x squared plus 5x minus 12 is going to be a 2x minus 3 and an x plus 4. So we can see a bunch of things going on there. We're going to recognize that the 3x plus 1's cancel, 2x minus 3's cancel, and x plus 4's cancel. All that's left is x plus 8 over the x plus 2. Now, as for the excluded values, like I said before, it's going to be everything that was relevant from the denominators and the original denominator. So that's why it's everything besides just the top left numerator. So just kind of going in order, the bottom left numerator, we'd get a negative 1/3 for the 3x plus 1. We get negative 2 for the x plus 2. The top right numerator, which was the original denominator, this one right there, 3x plus 1 already was counted for. X plus 4 gives us a negative 4. The new denominator, the 2x minus 3, gives us a 3/2, and the x plus 4 is already accounted for. So these are our excluded values, negative 1/3, negative 2, negative 4, and 3/2. Again, each of them coming from either the new denominators, or in the case of the 2x minus 3, the original numerator, because again, it had to be flipped when we did that. All right, so that's just your division step right there. Once you keep change and flip it, it really is another multiplication problem. And again, like with our just simplifying in 3.1, it really comes down to a lot of, can you factor a quadratic trinomial? As long as you can, these problems should not give too much difficulty. All right, so we simplified, we multiplied and divided. Our next video is going to talk about adding and subtracting, recognizing that with fractions, they have to have like denominators to add and subtract. So when they're unlike, something special has to happen. So I'll see everyone next time for that video.